Hi, so we're looking today at how 5G can be used to solve Factory 4.0 use cases, and how we can take that kind of step maybe a couple of years into the future and look at what the technologies could be delivering. We have a couple of kind of use cases we're looking at here. We're also looking at how this extends beyond the basic kind of factory floor and into kind of a wider 5G offering. So we're looking at how, for example, a low latency connection zone could be used to support robotic control, either the robots themselves or some kind of automated mechanism for delivering the parts to a production line. The second thing we're looking at is, well, cars are basically huge computers, and if you can put an eSIM into a car at the very start of the manufacturing process, you can combine the way that you build the computer components with the way that you build the car, and actually start to download the software very early in the cycle. So you can start to do automated download and testing very early on. For that kind of use case, you need high-speed download, and you also need that download to happen on a very kind of scheduled delivery. So you need to know that by the time you've reached a certain point in the process, you have downloaded the software so you can go and test it. So this is kind of within the factory. Once that car's gone out the factory gate, it's on a national network. Why not put an eSIM as well into that car within the factory, so as soon as it's outside, you can start to track it, you can start to get telemetry information. And so we think this kind of broadens the offer beyond just deploying onto the enterprise and selling equipment into a more rounded service provider offering. And then finally, we're looking at how you interconnect between the HQ and the factory to deliver that ability to look into what's happening within the factory from that HQ. So this is the sort of services we're looking at. I'll now hand over to Ollie, who'll explain how the back end in Cisco is delivering those functions.
Thanks, Mark. So what we have here is sort of a generalized picture of all of the network automation systems, the centralized control plane that exists within the service provider domain, and then at the very top, the exposure point of our managed service platform with the service operation northbound interface. And that's the integration point with the Amdocs order process system. So all of these pieces would exist within the service provider domain. And then the point being, within the enterprise domain, the focus is on the radio access nodes themselves and the mobile router, which terminates the traffic and presents it to the enterprise network. So whatever gets configured from the order process comes into this automation system. That then flows down. We have tenancy structure within the centralized packet core. We then deploy the network functions into the mobile router, and then configure the system from an end-to-end perspective. And then to join up the two domains themselves, what we actually do is deploy as part of the service an overlay SD-WAN link in order to be able to assure the connectivity between the service provider domain, where all the control plane functions exist, and the enterprise domain, where all of the radio access nodes exist. And so then what we end up with is an NFV platform with an internal configuration of the vRouter, an SD-WAN endpoint, user plane function for termination of the mobile network, with an access LAN and an enterprise LAN, and then a side route out across the SD-WAN link.